This is a very long question on conservation energy. And first up, in part AA part 1, find the loss in energy in the gravitational potential store. We realized that a decrease in height is actually 10 meters from A to B. So use the 10 meters in the MGH formula to get the answer. In part 2, what is the work done by friction on the car? So take note of the few quantities that will be relevant here. The car travels a distance of 120 meters. So you can see that this is the distance from A to B in green, and this is 120 meters all the way until here. And along this 120 meters worth of track, there is a constant frictional force of 250 newtons. So we use 250 newtons as the force of friction multiplied by the distance that the roller coaster move in the direction of the force, and it's 120 meters, and we get the answer 30,000 joules of energy transferred because of work done against friction by the car. Now, the motion of the roller coaster is always along the direction of the track, and which is the direction of frictional force. So the work done formula works perfectly here. Even though the direction keeps changing, the direction of the movement is always along the line of action of the frictional force. Now in part 3, therefore, what is the gain in the kinetic energy of the car when it reaches point B? So initial state is at point A, final state is point B. We use a low diagram to help us here. And initially there's a lot of GPE. At the end there is some GPE left. There is a kinetic energy at position B, and this is our objective. There is also energy loss transfer out of the system of the car because of work done by friction, 30,000 joules over here. So plugging everything in, that's how you can get the kinetic energy at B to be 50,000 joules. Now in part 4, in part B, that is a tricky part. The endpoint at C can actually be higher than B, provided that the work done against friction from B all the way looping up to C, the work done along this track BC is lesser than 50,000 joules. Now at point B, the object possesses 50,000 joules of kinetic energy on top of the GPE that it already has. So the GPE that it already has is able to bring the car up to at least the same height. If you want to go further up, well, there's a 50,000 joules of kinetic energy that can be used to be converted into GPE, additional heights at C. And what we need is that this additional 50,000 joules of kinetic energy is not depleted because of work done due to friction. Therefore, if the work done against friction does not exceed this 50,000 joules, it is possible for the endpoint of the track to be higher than B. And this is all to the question.